just further ahead compared to the time series. So there are several first generation panel unit tests. So actually, let's take a look. Panel unit test. So many economics time series, right, has a short sample, like what you normally deal with. Short sample, for example, if you have the data only available in an annual basis, right? So what you're going to do? Because we understand that there are several advantages we discussed before, why you want to proceed with the panel analysis, right? For example, we can get more information. We can pull that short sample period and then pull together, combine together with the several countries to estimate the in a panel setting, right? In a panel setting, so there are several advantages by proceed with the panel analysis. So that's why you see there are many economic time series has a short sample, So that's why we need to combine the result, right? Combine different cross-sectional and also the time series to estimate. So in order to deal with this spurious regression, then we can use the panel unit test to test for this integrated properties of this series. So the first one is called, means that the first unit test we call as a first generation panel unit. So actually it's to improve the univariate unit test. So actually why we want to proceed with the panel unit, because just now, for example, we run the full OS, right? Then we run the phase effect random effect. So do you want to know actually what is the properties of your series in a panel setting, right? You can run the univariate series not affected because of the small sample. Let's say if you only have 10 observation, then is it the result from the unit test still valid in the 10 observation? In the time series unit, not necessarily, right? Your result may be biased because you have the only 10 observation. So it will give you more information, or when we say you can test for the your properties of your series with the panel unit. So it will improve the power over the univariate counterpart. So this one, the first generation unit test is normally on a pool data. So you can test with the individual trend, also like the time series, variable intercept, and also the lag coefficient. So now, the first one is assuming the cross-sectional independence. This is the first generation unit. So, as we know, there is a drawback, right, from this univariate, because if you have a small or medium-sized sample, the power of the test might be affected. That's why we need to use the panel unit. Or maybe we can say that because of this small size sample, so your univariate result no longer valid, right, no longer reliable. So we want to estimate the panel analysis. So what we can say that we normally use as a panel unit test. Panel unit. So actually it's just you use the unit test applied to the panel data structure. So just use the unit idea applied to the panel data structure. So actually we have at least five different independent cross-section panel unit tests. We have at least 5. So which are the 5? We call it as Ladin, Lin, and Chu in 2002. So why is called Ladin, Lin, and Chu? Actually it's proposed by the test proposed by Ladin, Lin, and Chu in 2002. Once they're published, they name the test as the Ladin, Lin, and Chu 2002. Also applied to other tests as well. Breton 2000, Prasaranch and Shi 2003. We also have the Fisher test using ADF test and PP test, which proposed by Magala and Wu, 1999, and Choi 2001. We also got the panel stationary test, which is Hadri 2000. So why is a different? This Hartree test is different compared to other because this Hartree 2000 have a Hirschsprung stationary as a Hirschsprung. Stationary as a Hirschsprung. Other tests actually unit as a Hirschsprung. Unit as a null hypothesis, but for the Hartree is the other way around. So this is different compared to other first generation unit tester. But all the tests here require cross-sectional independence. So what is the result just now you test? There is a cross-sectional independence, right? Yeah. But this is based on estimation. How about based on the series itself? It means that you test the investment series for this template. If you test the CFP for this template, if you test the VAL for this template, is there got cross-section dependency? Yeah. So it's a different test. It's a different test compared to the cross-dependency test we discussed just now. Cross-dependency test that we discussed just now is a residual. It's based on the residual. But now this cross-section dependency is discussed about the series itself, only series, investment series, CFP series, AL series. Okay, so now let's take a look. Unit test based on the autoregressive process. So just like what we discussed for the time series, the y on the yt minus 1. Actually, it's a yit, right? The I here refers to the cross section. So y subscript it is a panel. It is a panel for your y series, y subscript it, and also y subscript it minus 1. So the rule, again, the rule here, if less than 1, then we can say that the series actually is weakly stationary. It's a weakly stationary. If the rule is equal to 1, means your y actually depends on y minus 1. So actually it's 1-to-1 relationship. Your current y actually affected by your previous y. 1-to-1 relationship. The p equals, means the rule equals to 1. Then actually the y contain a unit root. Contain a unit root is affected, right? Exactly 1-to-1. Then the y series actually contain a unit root. If your rule less than 1, so we can say that it's weakly stationary. It's weakly stationary. Yes. So there's the same idea like the time series unit root theory. So now, so this is the persistent parameter across the cross-sectional. So the pi equals to the p. So these are the assumptions. Your rho I equals to the p for all the I. It means they are same. So the rho are same for all the cross-sectional unit. So which are the tests to test for the cross-sectional common unit root process, like the LLC, Brindle, and also the Hartree. These are the 3 tests to test for common unit root process. To assume the P equals, the rule for the individual P is equal to the P for all. So they are same. So, but the hypothesis is different. LLC and Brindle, Hirschsprung is unit root. But for the Hartree, is no unit root, it's stationary as a null. So what is the basic ADX specification? So Stuart, can you recall your time series ADX specification? Time series. So almost same, right? Like this, right? But it's just without the I. Right? It's almost same without the I. Because it's the changes in the y. On the yt minus 1 is a time series ADX, right? It's a yt minus 1. And then the flag for your changes for your yt minus 1, right? But now we have a subscript I for each variable. And also the others variables, means that the other exogenous variable which contain the constant and as well as the time train, right, in the model number 1. So actually a similar unit test, you just assume the rho minus 1, right, is actually is alpha here to test this equation similar to test for the rho equals to 1. Okay. So the Hirschsprung is your unit root as a Hirschsprung against alternative your no unit root. No unit root This one is your hypothesis. Unit against no unit means that no stationary against stationary. Stationary as a alternative. So let's see the first test, LLC. Because as an LLC, aberration is LLC. This test is proposed by Levin, Lin, and Zhu in 2002. So there's something difference here because this estimate alpha means that the estimate one. So you can see derive the estimate of the alpha from the proxy from the changes for the y, and then the y are standardized rate of operation. So what is the difference compared to the basic IDF? So changes by IP, right? So still using the changes by IP, but now that they use that term. Let me see, the proxy after removing autocorrelation. Yeah, because you need to build a test free from autocorrelation and also the deterministic component. So they use that with this one, they adjusted. They use that the changes YIT with that bar. You see, actually it's removing the autocorrelation and also the deterministic component. So like this. So the difference here is they use with adjustment. Not only adjust for this dependent, and also adjust for the right hand side variable as well. So adjustment term for the mean and standard deviation. Okay. So now, if you want to use that LLC, right, to test for the LLC, so how are we going to do that? So you can see it's a common root. So what is the common root here? In a review, you treat that as a common root. So what is the common root here? Actually, the common root is assume that the PI is equal to the P. The root I equals to the P. So they are same to test for the common root process. So to test. So how are you going to test it? We go to the evaluate here. If I click on that, for example, INV, you just click on one of the variables, INV, for example. I go to view, and then I go to unit test. Then, once you click on unit test, there are two options. One is the cross-sectional independence, the other one is a cross-sectional dependence. So now I will start with the first generation pattern unit, which is the cross-sectional independence. We assume there's no cross-sectional dependency here. So we assume. So once you click on this, there's a panel unit test framework come out, right? The platform come out. Then the test type. The test type here. There's a start with a summary. Once you scroll down, actually these are the tests we're going to discuss today, which include the Levin, Lin, and Zhu, Bridle, IPS, Fisher, and Fisher ADF, and Fisher PP. So IPS, Fisher, these three tests, actually they are individual. So it's no longer PI equals to the P. So this one common root is they assume PI equals to the P for all the 10 foot, right? Including the argue. So I click on the Levin, Lin, and Zhu. So again, test for the unit root is testing to the level. Either first different, we first start with the level first, right? Then in the test equation, intersect and string or none. So as a normal practice, we start with the level, then test whether is that the unit root with the constant, right? Is it the investment series stationary at level with the constant in the models? And then here, automatic selection. So against my time series, my time just had 10 observation, I have 10 firms, so it's quite small, right? Yeah, that's why I based on the Scotch information criteria, based on the maximum length, right? Calculate based on my observation time only. So I use the maximum length as default. I just use that as start here. So I use the calculator to calculate the maximum length. And then you click OK. Once you click OK, then you can see my result, right? Our result is investment as your dependent variables, right? Yeah. Investment as my dependent variables. bin and 3.2024. Oh, this is based on modified SIC. Yeah, so the lag just now I choose based on the SIC. Actually, there's another criteria called modified, right? Modified. So then you will say, what is modified, right? So you will go to view, right? Go to unit test, cross-sectional independence, then automatic selection. Once you scroll down, there's AIC. There's a Scotch information criteria. There is also got Hannon Queens, also got modified version as well. So what is modified? Modified is like you said just now, it's like not the latest, right? To account the limitation in the size. That's why they come up with the modified version. So if you use the modified version, if you go through the Uniroot literature, right, there's some discussion the penalty between the SIC and also the modified version, right? Modified version. So as normal practice, we will use the SIC. If you want to argue one the reason for you to choose the modified version, right? Then should be the reason. There is a certain reason why you want to use the modified version. So let's say I want to replicate the result in my this version, modified one. Then once I choose the modified, then I click OK. Then it's 4.2. This is same. Yeah, 4.2004. It's a modified SIC. So p-value insignificant, right? Is insignificant. Then if you want to look at the individual case, then you can see the cross-sectional one up to 10 here. Then how about the legs, right? For each first, then maximum leg is 4. But the chosen one is here. Then with the band white and also with the observation. So if that's the result, then what you can conclude, right? Actually, is you feel to reject, right? You feel to reject. So your series investment actually is a Uniroot, right? Non-stationary is Uniroot. Then you actually also can test for first difference. You also can test for first difference. You go to view, like what you did for time series. Then it goes to the cross-sectional independence. Then you check for first difference. Is it my investment stationary one's difference, first difference? Then you click OK. Once you click OK, the test statistic now is negative 8.7. Right? Negative 8.7, p-value significant. P-value significant. So you can make the conclusion that your series now actually is a first difference stationary. Investment series is first difference stationary. Right? So it's not stationary at level, but first difference stationary. So I can say investment is I1. Then now we can try for other as well, right? You can try for CFP, for example. You go to view, and then check for the CFP. Go for the level, and then go for OK. If you go for the CFP series against LLC, also conclude that the series is non-stationary at level. Then how about in the first difference? Then I go to the first difference. So again, the series is stationary at first difference. Because significant, right? You reject the first now. So significant at first difference, right? You reject at first now, right? So it's significant. Significant means you reject your hypothesis. You reject your first now hypothesis. So we can say that the CFP also I1. So it's first difference only stationary. You also can test for VL later. Okay. Then how about Brittle? So this method, the Brittle 2000, is actually different from the LLC in a two different way. So the first one is the AR portion is removed. So you cannot see any autoregressive portion in the Brittle statistic. So just previously, there is the AR portion, autoregressive, right? This one, autoregressive.